Good morning. In the last videos, we have studied the topics atomic radius and ionization enthalpy and their trends along the period and down the group. This is from the chapter Periodic Classification of Elements of class 11th. A few questions were asked during those videos in between, the answers of which are being given now. So the first question was that how do atomic radius vary in a period and in a group, and how do you explain the variation? So the answer is that in a period atomic radius of elements decrease from left to right in a period because number of shells remain same but atomic number increase, hence increasing the number of protons in the nucleus, due to which the nuclear charge increases and electrons in the valence shell are pulled more towards the nucleus. And in the group, atomic radius of elements increase on moving from top to bottom in a group because down the group what happens? Principal quantum number increases, number of shells increase, valence electrons are farther from the nucleus. Also, the inner energy levels are filled with electrons which shield the outer electrons from the pull of nucleus, hence the size increase. The second question was, what are isoelectronic species? So as explained earlier, the atoms or ions which contain the same number of electrons are called isoelectronic species. So for example, O2 negative, F negative, Na positive, Mg2 positive and Ne, they all have 10 electrons in the shells in their elements. So they are isoelectronic in nature. Next question was, name a species that will be isoelectronic with each of the following atoms or ions. So the number of electrons in the species should be same. So for F negative we can write Ne or Na positive or Mg2 positive. Any of the species would be correct for F negative since they are having both the 10 electrons. For argon we can write Ca2 positive as they both will have same number of electrons, that is 18. Similarly for Mg2 positive we can write Na positive, and for Rb positive we can write Sr2 positive. These are isoelectronic. Next question was that why first ionization enthalpy of sodium is lower than that of magnesium but its second ionization enthalpy is higher than that of magnesium. For this we have first written the electronic configuration of sodium, Na positive ion, magnesium, Mg positive, Mg2 positive. So what we see that the first ionization enthalpy of sodium is lesser than that of magnesium because magnesium has extra stable configuration and smaller size, so it is difficult to remove electron from magnesium as compared to sodium. In sodium it is very easy to remove the outermost electron, that is in 3s, because after the removal of this one electron, sodium will become very stable due to noble gas configuration. But when an electron is removed from sodium, it acquires the stable noble gas configuration, whereas when one electron is removed from magnesium, it forms Mg positive with unstable electronic configuration. So when we will remove the second electron, it will be easier to remove from Mg positive than from Na positive, and therefore the second ionization enthalpy of Na is more than that of magnesium because Na positive has an extra stable configuration with complete octet, whereas Mg positive does not have an extra stable configuration. So the next question was that why Be has higher ionization enthalpy than boron. So the answer to this is that as we know that S electrons are attracted to the nucleus more than the P electron. So in beryllium what is happening, the electron removed during the ionization is from the S orbital, whereas the electron removed during ionization of boron is from the P orbital. So it is very easy to remove the electron from P orbital than that from the S, and therefore Be has the higher ionization enthalpy than boron. Next question was that why oxygen has lower ionization enthalpy than N and F. So if we compare the electronic configurations, we will come to know that oxygen lies between nitrogen and fluorine in the period. Oxygen is having the configuration of 1s2, 2s2, 2p4, whereas nitrogen is having 1s2, 2s2, 2p3. So the 1s2, 2s2, 2p3 electronic configuration of nitrogen is very stable as it is having 3 electron in its p subshell, which is the half filled stable configuration, due to which it is not very much easy for nitrogen to remove its outermost electron. So as compared to nitrogen, oxygen, even being smaller in size, show a different trend, and it has lower ionization enthalpy than nitrogen, because nitrogen is having half filled extra stability in its subshells, whereas the oxygen is having lower ionization enthalpy than fluorine, because of course oxygen is larger than fluorine, as we know that ionization enthalpy is inversely proportional to size. The logic will be appropriate here, that since oxygen is larger in size, it will remove its outer electron very easily than fluorine. The trend was exceptional for nitrogen and oxygen. Nitrogen was having larger size than oxygen. Still it is difficult to remove electron from nitrogen than oxygen because of the half-filled stable configuration of nitrogen. Thank you.